The National Electrical Code, or NEC, addresses arc fault circuit interrupters AFCIs in dwelling units. Specifically, the 2005 NEC requirements dictate the installation of AFCIs. This requirement applies to 15 and 20 ampere, 120 volt branch circuits. These circuits must supply outlets or devices installed in habitable rooms, including dormitory units. The intent is to provide enhanced protection. This protection is against electrical fire stemming from arcing faults in electrical wiring. AFCIs are designed to recognize arcing faults. They interrupt the circuit rapidly. This prevents the arcing fault from igniting surrounding materials. Let's delve into the specific aspects of this code alert. Firstly, the purpose is to clarify the NEC requirements for AFCI installation. This applies to all 15 and 20 ampere, 120 volt branch circuits. These supply outlets or devices in habitable rooms, including dormitories. Secondly, the background explains the NEC 2005 mandate for AFCIs. This applies to the specified circuits in habitable rooms and dormitories. The goal is to bolster safety against electrical fires due to arcing faults. AFCIs detect the unique signature of an arcing fault. Thirdly, the scope details the application of the AFCI requirements. This applies to all 15 and 20 ampere, 120 volt branch circuit serving outlets or devices in habitable rooms and dormitories. This encompasses circuits for lighting, receptacles, switches, and other electrical devices. Fourthly, certain exceptions exist. The AFCI requirements do not apply to the following circuits: 1. Branch circuits powering smoke alarms. 2. Carbon monoxide alarms. 3. Other life safety equipment. 4. Branch circuits feeding fire pumps. 5. Other emergency equipment. 6. Branch circuits powering industrial machinery. 7. Other equipment not typically found in habitable rooms. Fifthly, enforcement is mandatory. Electrical inspectors must enforce the NEC 2005 requirements for AFCI installation. They verify that all applicable circuits in habitable rooms and dormitories are AFCI protected. For additional information, resources are available from several organizations. 1. The National Electrical Manufacturers Association, or NEMA. 2. The Electrical Safety Foundation International, or AFCI. 3. The National Fire Protection Association, or NFPA. For further inquiries, you can contact the National Electrical Manufacturers Association, or NEMA. In essence, the NEC 2005 mandates AFCIs in specific circuits within dwelling units. This mandate aims to prevent electrical fires caused by arcing faults. AFCIs are designed to detect and interrupt these faults swiftly. This minimizes the risk of fire ignition. Electrical inspectors are responsible for enforcing these requirements to ensure safety. It's crucial to understand the scope, exceptions, and enforcement aspects of this code. This understanding is essential for compliance and safety. Let's examine the technical considerations for AFCI implementation. AFCIs are sophisticated devices. They monitor the electrical current for unusual patterns. These patterns signify arcing faults. Traditional circuit breakers respond to overloads and short circuits. However, AFCIs detect the specific characteristics of an arc. This includes erratic current fluctuations and high-frequency noise. There are two primary types of AFCIs. One is the branch/feeder AFCI. 2 is the outlet branch circuit AFCI. Branch/feeder AFCIs are typically installed in the electrical panel. They protect the entire branch circuit. Outlet branch circuit AFCIs are installed at the first outlet on the circuit. They protect the downstream wiring and outlets. The selection of the appropriate AFCI type depends on the specific application and wiring configuration. Proper installation is critical for effective AFCI operation. This includes ensuring proper wiring connections and grounding. AFCIs should be tested regularly to verify their functionality. A test button is typically provided on the AFCI for this purpose. The testing process simulates an arcing fault. It confirms that the AFCI trips the circuit. When an AFCI trips, it indicates a potential arcing fault. It's essential to investigate the cause of the trip before resetting the AFCI. This may involve inspecting the wiring, outlets, and connected devices for damage or loose connections. Ignoring repeated AFCI trips can lead to a fire hazard. The NEC provides specific guidelines for AFCI installation and testing. These guidelines should be followed carefully to ensure compliance and safety. AFCIs are an important safety device. They help to prevent electrical fires caused by arcing faults. Proper installation, testing, and maintenance are essential for their effective operation. Consider the practical implications of AFCI implementation in residential settings. In older homes, the existing wiring may not be compatible with AFCIs. This can result in nuisance tripping. Nuisance tripping occurs when the AFCI trips due to normal electrical activity. This is misinterpreted as an arcing fault. In such cases, it may be necessary to upgrade the wiring. This upgrade ensures compatibility with AFCIs. The NEC provides exceptions for certain situations. This includes where existing wiring does not have a grounding conductor. However, these exceptions should be carefully evaluated. They should be implemented only when necessary. Homeowners should be educated about the importance of AFCIs. They should be trained on how to test and reset them. This education promotes a safer living environment. Electrical contractors should be knowledgeable about AFCI requirements. They should be skilled in their installation and troubleshooting. This ensures that AFCIs are installed correctly. They perform their intended function effectively. The cost of AFCIs is typically higher than traditional circuit breakers. However, the added protection they provide against electrical fires justifies the investment. In conclusion, AFCIs are a crucial component of modern electrical safety systems in dwelling units. Their proper implementation helps to prevent electrical fires. This protects lives and property. Continuous advancements in AFCI technology improve their performance. This reduces nuisance tripping. Staying informed about the latest NEC requirements. It ensures that electrical installations are safe and compliant. The NEC requirements for AFCIs are not static. They evolve over time to reflect advancements in technology. They address emerging safety concerns. It's important to stay updated on the latest code revisions. This ensures that electrical installations meet the current safety standards. The NEC is updated every 3 years. This incorporates new research. It incorporates field experience. It incorporates technological developments. Electrical professionals should participate in continuing education courses. This helps them stay abreast of the latest code changes. These courses cover topics such as AFCI installation, testing, and troubleshooting. They provide practical guidance on how to implement the NEC requirements effectively. The National Fire Protection Association, or NFPA, offers a wide range of resources. These resources support electrical safety education. These resources include training programs, publications, and online tools. These resources help electrical professionals stay informed and compliant. The Electrical Safety Foundation International, or AFCI, also provides valuable resources. These resources promote electrical safety awareness among consumers. These resources include educational materials, safety tips, and online resources. These resources help consumers understand the importance of electrical safety practices. Collaboration between industry stakeholders is essential. This promotes electrical safety. This collaboration involves electrical manufacturers, contractors, inspectors, and educators. This collaboration fosters a culture of safety. This drives continuous improvement in electrical safety practices. The use of AFCIs is not limited to dwelling units. They are also used in other applications. This includes commercial buildings, industrial facilities, and healthcare facilities. In these applications, AFCIs provide enhanced protection against electrical fires. This safeguards people and property. The specific AFCI requirements may vary depending on the application. It's important to consult the NEC and other applicable standards. This determines the appropriate AFCI requirements for each situation. The proper selection and installation of AFCIs are critical. This ensures their effective operation in all applications. In addition to AFCIs, other electrical safety devices are also available. This includes ground fault circuit interrupters, or GFCIs, and surge protective devices, or SPDs. GFCIs protect against electric shock. SPD protect against voltage surges. These devices work together to provide comprehensive electrical safety protection. The selection of the appropriate electrical safety devices. This depends on the specific application. It depends on the electrical system characteristics. It depends on the potential hazards. A qualified electrical professional can assess the risks. They can recommend the appropriate safety devices. Regular inspection and maintenance of electrical systems are essential. This identifies potential hazards. This prevents electrical accidents. This includes checking for damaged wiring, loose connections, and overloaded circuits. Any identified issue should be addressed promptly. This ensures the continued safe operation of the electrical system. Electrical safety is a shared responsibility. This involves electrical professionals, homeowners, business owners, and consumers. By working together, we can create a safer electrical environment. This protects lives and property. The information provided in this narration is for educational purposes only. It should not be considered a substitute for professional electrical advice. Always consult with a qualified electrical professional. This ensures that electrical work is performed safely and in accordance with applicable codes and standards. Continuous learning and improvement are essential. This advances electrical safety practices. Staying informed about the latest technologies, codes, and standards. This helps to create a safer electrical world for everyone.